So, hello Miss Landa. Right now, Stephanie, Chris, Pritish, and I from Group 7 are going to present our final report. So, in question 1, the research objective is to find variables that significantly affect body fat. The dependent variable is body fat. So, here are the 15 independent variables in question number 1. This is the output for the parameter testing. This is the output that will be used in the simultaneous testing. And p-value is less than alpha, then we reject H0. Therefore, we can decide that there is an effect of those independent variables in the value of body fat simultaneously. Thus, we have to do partial testing to check whether those independent variables individually give significant effect or not. In partial testing, if the p-value is bigger than alpha, we accept H0, indicating that there is no significant effect, and vice versa. This is the output of partial testing from RStudio, and from partial testing, we found that variables that give significant effect are weight, BMI, FF weight, chest, abdomen, thigh, forearm, because of the p-value is less than alpha. Then we create a new model without the insignificant variables. So this is the output for the new model. And in the new model, the p-value is less than alpha. Then we reject H0. Therefore, we can decide that there is an effect of those independent variables in the value of body fat simultaneously. And from the new model, all of the p-value is less than alpha. Thus, all of them give significant effect partially. The value of adjusted R-squared is 0.9673. This means that 96.73% of the variability of the data can be explained by the model. This value is very high. Therefore, we can decide that the model is good to explain the data. So this is the syntax from assumption testing. It can be seen that there is a linear trend in the data. Hence, the assumption of linearity is satisfied. These are the linearity of the model for each variable. The majority of the variables have a linear trend in the data. Therefore, the assumption of linearity are satisfied. There is no particular trend in this plot, so the assumption of independence of error plots is satisfied. The majority of the points are located in the diagonal line. Thus, we can indicate that the normality assumption is satisfied. The plot shows a straight line. Therefore, the assumption of equal variance is also satisfied. From the outlier plot, it can be seen that the data consists of 3 outliers, which are 39, which is a very extreme value, 192, and 221. To make the new model more accurate, the outliers could be removed. So this is the formula. We can interpret the formula that body fat can be found by inputting all of those variables. And if the variable is positive, for example, in the variable of weight, if the weight increases a unit, the value of body fat will increase 0.36 unit. If the value is negative, for example, if the BMI increases 1 unit, the value of body fat will also decrease 0.49 units. So the next question will be explained by Pritish.
My name is Pritish. Today I'm going to be explaining about question number 2. In question 2a, the research objective is to analyze whether there is a significant effect of race to the science score by using one-way ANOVA. The dependent variable is science score and the independent variable is race. In this case, there are 4 different groups of race, which are 1, 2, 3, and 4. As shown, this is the syntax and output for this hypothesis. In this case, the p-value is less than alpha. Therefore, we must reject H0. Therefore, we can decide that there is a significant effect of race to the science score. After knowing that there is a significant effect, we need to do a post-HOC test for further analysis. As we can see, this is the output of the post-HOC test for each pair. In this case, the p-value is larger than alpha. This means that there is no significant difference between the raise 2 and the raise 1. In this case, the p-value is again bigger than alpha. This means that there is no significant difference of the science score between raise 3 and raise 1. In this case, the p-value is less than alpha. This means that there is a significant difference of the science score between the raise 4 and the raise 1. In this case, the p-value is bigger than alpha again. This means that there is again no significant difference of the science score between the raise 3 and the raise 2. Again, in this case, the p-value is larger or bigger than alpha. This means that there is no significant difference of the science score between the raise 4 and the raise 2. When comparing between raise 4 and raise 3, the p-value is less than alpha. This means that there is a significant difference between the raise 4 and the raise 3. Next is the number 2b. The research objective is to analyze whether there are significant effects of study program and school type of the students to their reading score by using two-way ANOVA. The dependent variable is reading score and the independent variables are study program and school type. In this case, there are three different groups of study program, which are 1, 2, 3. And there are two different type of school types, which are 1 and 2. As shown, this is the syntax and the output for the parameter testing. From the output, the p-value of the study program is less than alpha. This means that there is a significant effect of the study program on the reading score. Whereas the p-value of the school type is bigger than alpha. This means that there is no significant effect of the school type on the reading score. As shown, the p-value is less than alpha, which means again there is a significant difference of the reading score between study program 2 and study program 1. In this case, the p-value is bigger than alpha. This means that there is no significant difference of the reading score between study program 3 and study program 1. In this case, the p-value is less than alpha. This means that there is a significant difference of reading score between study program 3 and study program 2. Finally, in this case, the p-value is bigger than alpha. This means that on average, there is no significant difference of the reading score between school type 2 and school type 1. Thank you. Next, for question number 3.
My name is Stephanie Pierce, and now I'll explain number 3. In question 3, the research objective is to find variables that significantly affect death cases in India. The dependent variable is deaths, and the independent variables are total population, area, and total cases. The dataset is already attached in the same Google Drive folder. So this is the output to find the significant variables. P-value is less than alpha, so we have to recheck HO. Therefore, there is an effect of those independent variables in the value of deaths or simultaneously. Thus, we have to do partial testing to check those independent variables individually. From partial testing, we get the significant variable is only the total cases because the p-value is less than alpha. And now this is the output of the new model without the insignificant variables. Because there is only one significant variable, thus the result between simultaneous and partial are the same. P-value is less than alpha, therefore we can decide that there is an effect of the independent variable in the value of deaths. The value of adjusted R squared is 0.88 88.72. This means that 88.72% the variability of the data can be explained by the model. This value is very high, indicating the model is good to explain the data. After that, we do the assumption testing. From the linearity plot, there is a linear trend in the data, hence the assumption is satisfied. From the independence of error plot, there is no particular trend, so the assumption is satisfied. From the normally errors of plot, the majority of the points are located in the diagonal line, thus the assumption is satisfied. The assumption of equal variance is satisfied because the plot shows a straight line. From both outliers plots, it can be seen that the data consists of three outliers which are 1, a very extreme value, 2, and 3. To make the model more accurate, the outliers could be removed. This is the final formula that can be found by inputting the independent variable. If the total cases increases 1 unit, the value of that will increase 1.3802 units. That's all from us. Thank you, Ms. Mande.